So today we're going to look at geometric mean in the context of similar right triangles. So before we begin, we're going to go over this very first warm-up question, and then we're going to dive right into the content just for sake of time. So an altitude is basically the height of something. So you may have heard them say on an airplane, if you've ever flown, our current altitude is however many thousands of feet that you are up in the air. So when we're talking about a triangle, it's that vertical height from the base to the tip vertex of that triangle. So let's remind ourselves of what geometric mean is. So a geometric mean of any two numbers is whatever we get when we set that number over x equal to x over the other number. So essentially what we end up with is the geometric mean of any two numbers is the square root of those two numbers multiplied together. So when I start with 9 and 18, when I multiply those two things, I'm going to get 162. And then I want to see, is there a perfect square that divides into 162? There is. 81 goes in twice. The square root of 81 and the square root of 2 can separate. The square root of 81 is 9, so 9 square roots of 2 is our geometric mean. For 10 and 30, we're going to go ahead and multiply those together. That gives us the square root of 300. 300 is divisible by the perfect square 100 3 times. And the square root of 100 is 10, so 10 square roots of 3 is our geometric mean of 10 and 30. So how does that apply? So in your notes, you may want to jot down this particular theorem because that's going to give us all of our information for today. So if the altitude is drawn to the hypotenuse of a right triangle, so basically if we have one 90-degree angle connected to the other, then two triangles that are formed, the one on the left and the right, are similar to each other as well as the original triangle. So you'll notice down here they've redrawn those three triangles so that we can see the tiny triangle on the right in blue, the one on the left turned and drawn in red, and the original figure turned and drawn in black. Pause the video as needed, and we're going to go ahead and proceed. So with this particular picture, we want to identify the similar triangles. So first and foremost, we're going to take a look at the smallest triangle. So I notice that because I have a 90-degree angle on the left, I'll have another 90-degree angle there on the right because those are a linear pair. So this is angle U. US is my smallest side, so I'm going to put S here and put T here. So I've got my smallest triangle redrawn. Then I'm going to look at my medium-sized triangle. Again, our 90-degree angle vertex is U. Our smaller side is UT, and my longer is UR. And now I have the second triangle drawn. So looking back at the original figure, my right angle vertex was T, my smaller side was TS, and my longer side was TR. Now that I have them redrawn, I can set up ratios just like I always would. So I could say TR over TS equals RU over UT equals TU over S, and so on. I could form all sorts of different proportions that would be true due to the fact that all three of these are similar. So that's exactly what we're going to do. We're going to redraw these three triangles and we're going to try to find the missing link. So for this smaller triangle here, our vertex is M for the 90-degree angle. MS is the smaller side. And then I'm going to label what I know. I know ST is 64. And I know MT is labeled as H. Then I'm going to look at this figure on the left. M is again my 90-degree angle. MT is my smaller side. And MR is my larger side. I'm going to rewrite that R because I wrote that as an M. And then we're going to fill in what we know. We know RT is 152. be careful that 165 is representing all of that, so we don't know what that particular part is. And we know that m to t is labeled as h. Last but not least, we're going to look at the original figure as it stood. So the original figure had a right angle at vertex T. TS is the smaller side. And then we're going to fill in what we know. TS is 64. RT is 152. And we know that RS is 165. Now what's nice about this particular example is we have one triangle where we know all of the given information. So I can use that original largest triangle and the fact that it's similar to the other two to solve for h. So for example, I could say 165 over 152 should equal 64 over h. I could have also said 165 over 64 would equal 152 over h, and that would work as well. As long as you set up your proportion correctly, you should still end up with the same answer. So if I solve this proportion, I end up finding out that the height ends up being about 60. So I've rounded here a little bit, but that's about 60 inches for our height. Anytime that we need to round in this class, if it doesn't specify, we're going to round to the nearest tenth. But in this case, when we round up, that does cause us to have to round again, which leads us to 60 inches. So what we just found is that the distance from here to here is 60 inches approximately. And then what they're looking for is the maximum depth of the pool. So we want all of that. So I do need to add my 48 inches that I have at the top, and my approximate depth is about 108 inches deep. So let's try one where we've got the three triangles here. Again, for this type of problem, we're always looking for one 90-degree angle with an altitude drawn from it. And we're going to redraw these three triangles. So with this in mind, our shortest leg of this triangle, remember that legs surround those 90-degree angles, our shortest leg is 4, our longer leg is x, and my hypotenuse is z. Then I'm going to look at this medium-sized triangle. My 90-degree angle is here. So my shorter of the two legs is x, my longer is 9, hypotenuse is y. Then we're going to look at the whole thing. So my 90-degree angle was right here originally. My shorter leg was z, longer leg is y, and my hypotenuse is all of this put together, so 13. And now what I can do is I can play around with my different ratios to find the value of x, y, and z. So for example, if I'm solving for x, I notice that there are no x's in that first largest figure. So I'm essentially going to pretend that's not here for a moment, and I'm going to set up that 9 over x should equal x over 4. And notice we have that geometric mean set up here, so that's how this ties back in to our similar right triangles. So we're going to cross multiply. X squared equals 36, which means x is 6. When I'm solving for y, I notice there are no y's in that far right figure, so I'm going to ignore the far right figure for a moment, and I'm going to set up y over 9 equals, I don't want to pick this side because it's also a variable, so instead I'm going to say 13 over y, cross multiply, and instead of multiplying those two numbers, I've got 9 and 13, but 9 is a perfect square, so 3 square roots of 13. Last but not least, we need to find the value of z. I notice that z is not in that middle picture, so I'm going to ignore the middle picture for a moment. And I'm going to set up z over 4 equals 13 over z. And I'm going to cross multiply. Again, once I do this, I've got 4 times 13, but because 4 is a perfect square, when I take the square root of that, z equals 2 square roots of 13. Now this process takes a long time, but it will work every single time. So if you like this process of redrawing these 3 triangles, you may use this for every single case of these types of problems. But I'm also going to show you a shortcut or a memorization trick that you can use that will work every time as well. So you can just memorize this formula if you would prefer. It says the altitude equals the square root of the number on the left side times the right side. So looking at this particular example, this is our altitude, that height of the triangle, if you will. So x should equal the square root of 2 times 8. That becomes the square root of 16, which we know is 4. Remember guys, when we take a square root, we technically should put positive or negative 4. However, since this is geometry and this is a distance, positive 4 is our only valid answer. So again, if you're solving for an altitude, or if you know the length of that altitude and you're looking for one of these 2 parts of the hypotenuse, we can just memorize the phrase altitude splits, which means the altitude equals the square root of the number on the left times the number on the right. Now notice with this formula, we have not talked about these 2 parts at all. So our next formula is going to give us a way to find those 2 missing pieces. And this phrase is legs round. So legs round says the leg will always equal the square root of the first number on the hypotenuse as you round the corner. And I know that's a little bit strange, so we'll talk about what that means. So the first number on the hypotenuse as you round the corner times the total of the hypotenuse. So if we're looking at this, our 2 legs are here and here. And I would recommend that you always highlight those because our formula only works for those 2 sides. So if I want to find z, z should equal the square root. The first number I hit is 2 times the total of the hypotenuse, which is 10. So z becomes the square root of 20. 20 is divisible by the perfect square 4. And the square root of 4 is 2. So 2 square roots of 5. Whereas if I'm solving for y, the first number I hit as I round the corner to the hypotenuse is 8, and my total is still 10. So I end up with the square root of 80, which is divisible by what perfect square? So I know 4 is going to go into that, but I think 16 will as well. So 16 goes into that 5 times. Square root of 16 is 4, so 4 square roots of 5. Again, if you're not a great memorizer, you can always redraw these triangles, but this is a trick that will work every single time. It just requires some memorization. So let's do these couple of examples here using the shortcuts that we have. And what we're going to do is we're only going to look at this one right here as our example, and then we're going to close out our notes today. However, I'm going to have you add x and z to this picture. So looking at this, y is my altitude. That's the height of that figure. So my altitude should equal the square root of the number on the left times the number on the right. So y should equal the square root of 5 times 8, which is the square root of 40. 40 is divisible by 4 10 times. Square root of 4 is 2. So y is 2 square roots of 10. And again, we're going to ignore this guy. We're only looking at the one on the right. So I'm going to use my space here. My two legs are x and z. So the leg should equal the square root of the first number you hit as you round the corner to the hypotenuse times the total of the hypotenuse. So x should equal the square root of 5 times my total, which is 13. And if I look at that, 5 times 13 becomes the square root of 65. That's not divisible by any perfect squares. So the square root of 65 is my final answer. And z is also one of the legs. So for z, as I round the corner, the first number I hit is 8. And the total is 13. 8 times 13 becomes 104. I know 104 is divisible by 4. So I'm going to rewrite that as the square root of 4 times 26. The square root of 4 is 2, so 2 square roots of 26 is my value of z. Again, if you're not a memorizer, just redraw the 3 triangles just like we did in the first example. You'll still end up with the same answers. This method just saves you a little bit of time. Guys, thank you so much for your attention and have a great day.